Welcome to one of the important topics, user-defined packages. In this lesson, you are going to learn how to create a package of your own and how to make use of it. In our previous lesson, we have seen what is a package and what are the important inbuilt packages are there. Package is basically a container which contains all related classes and interfaces. There are two categories of packages. One is inbuilt package and other is user-defined package. That means the package that we create and we use it of our own while doing projects or real-time applications. So in our previous class we have seen 5 important inbuilt packages and we have taken an example of scanner class and we have used it, and we know now at least some basics of packages we already had. Using that basic knowledge, now we'll try to create a package of our own and we'll try to use the package that is created by ourselves. Before I start this lesson, I'm telling you one point. This is the most confusing lesson, but it is very important and I need your concentration. Full concentration is required here, and you cannot sit relax. There are some topics I'll tell you to sit relax, but please sit tight. 40 minutes down, you are going to have wonderful concept in your hand. Agenda for today, we are going to create user-defined packages, and the second point is very important. Understanding access modifiers. This is very important. So far I didn't talk anything that is related to access modifiers. As of basic knowledge, you know only 3 points. A class has two things. One is variable and other is functions. Either a function or a variable can have an access modifier like private, protected, public. These 3 things you already know. So protected is used in case of inheritance, and if you want to make a variable or a function that to the public, as a public means anybody can access at any point of time. Public means public, that's all. Okay, anyone at any point of time within the package or outside of the package, they can access that particular variable or a method if you make it as a public. Private means no, other than class members you cannot access anyone. So with respect to package, now a new concept is added to it. Here is a place where we need to link up everything and we need to learn access modifiers a lot. And finally, we'll try to put everything in reality, like we'll try to write at least few programs, like 3 or 4 programs to understand the access modifiers and packages, user-defined packages, okay? Roughly, we'll see the syntaxes and then we'll get into the work. Creating a package is dead easy, very easy, super easy it is. If you wanted to create a package, you already know package means logical arrangement of related classes, okay? Let us imagine in a file you have 3 classes, class A, class B, class C, okay? You can keep these 3 classes in a package called as demo, as in the way I've shown you there. Package demo. Demo means a name that is given to the package. In any Java file, if you include this line, first line, it means that whatever the classes that you are going to write within this Java file will belong to automatically this particular to this particular package. In our previous class, I told you package is just like a logical arrangement of files, which is very much similar to folder at an operating system level. Demo is just a folder. Make sure that demo is a folder that is existing before compiling this package. Demo should be a physically available folder in which all these class files will be generated. So you don't have to worry, just keep this point in your mind, and anyhow everything I'm going to show you by executing. I'll be writing programs in front of you and I'll be demonstrating the access modifiers, everything I'm going to tell you. If you wanted to create any package, then just add one simple line. It is just like how exactly you have been writing Java programs. In the same way, you keep writing the programs, and if you want the classes of that particular program to be included in a package, then add this line. That's all. Package demo. So here demo is a package name. In this particular Java file, how many ever classes that you have created, all those classes obviously will belong to a package called as demo. So later, after compiling this particular program, and later whenever you want, you can access the classes that belongs to demo package within this same package and outside the package also. So you can access them. So that is the advantage. Advantages of packages was already done. You can watch that video in case if you were absent yesterday. You need to know once a package is created, how to use it. For an example, how did we use yesterday? We have in our previous lesson we have used a package called as util. Util is a package. So the complete name of util is java.util, because util is a package that is available in the base directory or the base package called as Java. Java.util is a package. How did we import? Just imagine the program that we have done already. It's so simple, right? Import java.util dot the class scanner. This is what we have written in our previous class. Now in the same way, the same rule applies here. In case if you wanted to use the package that is created by you, in our previous example, we have created a package called as demo. Now if I wanted to use this demo, so I need to write a statement, the same statement. The statement never changes. Import. Import is a statement that is used to take the required packages, whatever the necessary packages that you want to complete your task. All those packages have to be imported using a simple statement called as import. This is what we have done yesterday and this is what we are doing today. Import. But the thing is here, demo. In previous lesson, we have seen import java.util. Java.util was a predefined inbuilt package. Now demo.a, it is user defined package. Now tell me, demo.a, what is package and what is class? Demo is a package. Inside demo, a is the class that I want class a in my program, in my current program sample, in my current class sample. Here I want some features of a. A is a class which is not part of this program but which is part of package demo. Every Java class belongs to one particular package. Definitely. If you are writing a Java class, definitely that has to belong to one particular class. You could ask me, sir, we have written around 10 programs and none of the programs we have used the concept of package. Then what are the packages? Package name we haven't given. So to which particular package those programs went? They went to an unnamed package. Okay, the package which is not named at all. If you skip using line package space package name, then obviously that belongs to an anonymous unnamed package. Here onwards we'll be writing packages because we'll try to relate the classes that we create to a particular package. So here in our previous case, we have created a package called as demo and there is a class called as a. In case if I want to use class a, then I need to import package demo, and inside demo you might be having so many classes. Which class you want? A. Class A I want. Import demo.a. This is what we have to write. Note one thing, there could be any number of packages. Outside the demo package, if I wanted to access any class that belongs to a demo package, then only I need to use the statement import. Within the same package, if you want to import any class, you can import directly without using import statement. This is what I have written note here. Note import is used for Java files which are outside of package. For example, sample class is outside of package demo. Since we are far away and demo packages which is different from the current package, and I want class A which belongs to demo, that's why I'm using this import statement, import demo.a. In case if you wanted to import any class that belongs to the same package, demo, then you don't have to worry, you don't have to import, you don't have to write import statement because you already belong to the same package. You can directly access that class. In case if you have created a package like this, okay, look at here, this is the demo package, right? It's a demo package. Inside demo package there are some classes. Class A is there, class B is there, class C is there. Or imagine that there is only class A is there and the package is demo. Class A belongs to demo package. Now, how do I compile this class? During compilation, generally the compilation command is javac space your file name .java. That is the compilation. But to make Java to understand the classes that are created in that particular file belongs to a particular directory and the directory name is mentioned with the name package. To tell this thing to the Java environment, we need to use this command. It is routine command. You don't have to worry. Additionally, in case if you wanted to compile the file in which you have created a package, okay, if a file consists of a line package space package name, then you need to use this command. Here javac-d means consider the directory. In case if directory doesn't exist, a new directory will be created. Space dot sample dot java. For an example here, in case if you are compiling this particular program, okay, this program you have written and your intention is to add class A in a package demo, and while compilation, this class dot class file after compilation will a dot class file will be generated. That means a dot class will be generated. That a dot class has to be available in a folder called as demo. You can also physically create a folder demo and you can keep this dot class file inside it. But your Java environment during runtime, it cannot relate which package is available in which particular directory. During compilation, if you do it, while creating the class file itself, it writes in bytecode. While creating the bytecode itself, it tells this class relates to this particular package directory. So it's very important to use this command javac space -d dot sample.java. Sample.java is the file name that I wanted to compile this file name, java.sample, and -d. In this sample.java, I have written package demo. So a demo folder will be created in case if it is not available. If it is not already created, a new folder will be created, and whatever the classes are there with respect to .java, all those class files will be kept in that particular demo folder. Now demo is just like a physical folder in which you have classes, okay, .class files. Whoever want to import those class files, they can import by following the rules of access modifiers. They can use them. Note, directory demo will be created and class files are stored in it, okay, and a class file will be stored in it. In case if you have only one class, then that class, in our case a dot class will be created in a folder called as demo. Demo is a package. It is clearly visible to you. It will be visible like a folder. Alright, now next, one more important thing. To execute a class file demo, for an example, if you have created a class file, let us imagine the class file is demo, and if you wanted to execute it, then you should come out of the package and you need to give this execution command. To execute any Java program, you already know, you need to use the command java. Let us imagine that a class file is demo. Usually you will be writing java space demo in case if your demo is your program name, or else like your public class name is demo, then you will be writing java space demo. Your program will be executed. Unlike the programs that we have done so far, here in case if you wanted to execute this class file that belongs to a package p1, then the package name has to be mentioned, java space p1.demo. What did you understand? Demo is the class name that you wanted to execute this class, public class. Upon execution, you will be seeing some output, doubtlessly. This demo class belongs to a package called as p1. Since it belongs to p1, during execution you need to give the package name like this, java space p1.demo. So this is how we compile the packages and we execute the files that belongs to a particular package. So two simple commands you have seen. javac, any file name .java is already known to you. Additionally, you have -d space your file name .java. This is for compiling your packages, and to execute any class file that belongs to a package p1. This is the example. Java command, your package name class file name. Focus. I need your concentration. This table is very important, and it's very easy to remember, and only if you concentrate about 5 to 10 minutes, I'll be demonstrating this table content, and please listen carefully. This table content is very important for all types of academic exams, for all types of placements. This topic can be best taught only the moment we have started the topic packages. Before we start packages, and you can't understand, even if I demonstrate this table, you can't understand anything else. Now it is correct place, correct time to learn access modifiers. Now look at here. Concentrate. Look at here. These are the modifiers we have in Java. Public, protected, private. These three you already know. There is one more thing which is default. What do you mean by default? If I say public int a is public. If I say private int a is private. If I say protected int a is protected. What do you mean by simply int a? I did not give any access modifier. If I have said int a, what do you mean by that? Int a means, will you be blindly considering it as private, or blindly will you be considering it as protected or public? No, it is default, just default, that's all. Nothing is specified, okay? Don't blindly consider public or protected or private in case if access modifier is not specified. It is considered as default, and default has separate rules and regulations. Default means it's not public, it's not protected, it's not private. It is something else other than these three. The name itself, you just remember it as default. Whatever I am going to talk now with respect to this table is related to class member access. What are the properties of class? Only two properties, costs and billings. Like class has variables and operations, functions. These are only the properties of class. Anybody wants to access these two only, either variables or functions of a class. So variables and functions have to be protected using these modifiers: public, protected, default, private. If you want your variable to make it as public, then make sure that variable can be accessed by any class member by creating an object. Anybody can see that variable's content if you make it as public. And if you make it as private, nobody can see it other than within the class. So that is the meaning. In case if you make it as protected, nobody can see other than class members, plus additionally subclasses. That means child classes, whoever inherited from this base class can also see that particular thing. Protected is a keyword that I already demonstrated as part of inheritance. In case of any absent is, please check out my previous videos. Concentrate now within the class. Here there is no concept of package. In this column there is no concept of package. Okay, within the class, look at here. Within the class, if variable is set as public, anybody can access. Cool, right? Within the class, if a variable or a function is set as protected, still you can access. Within the class, if nothing is specified, still you can access. Within the class, if variable is set as private, still you can access. So within the class, if any function can access private variables, public variables, protected variables, and default access modifier variables and functions. Okay? Within the class, access modifier has no role to play. Got my point? For an example, you have created one variable like int a, and you made int a as private. Within the class, there are two functions. Let us imagine function 1 and function 2. These two functions can access variable a content even though it is private. Because just imagine, we being belongs to a particular family, okay, we are never private. In your home, you are already a family member and you are never a private member. Only outsiders are private to you. Within your family, you can access. Within your house, you can access anywhere, any place, any bedroom, hall, kitchen, you can access. You can access them because you are a family member. I cannot access your house because I am not a family member of yours. I am an outsider. So here, I just wanted to make you understand. Okay, within the class, there is no restriction at all. You can access whatever you want. So that's why all S. Now, within the package, like you just imagine your apartment with all flats as one particular package. And opposite apartment is not your package, right? Opposite apartment is something different and your apartment is something different. Within your apartment, your flat is something different. I hope you got the point. Now, within the package, how these access modifiers play a role, now let's look at here. If you have created any variable int a and if you said it as public, not only the class members, not only the family members, but also within the package, that means within the apartment, okay, anybody can access it. Got my point? Anybody can access it. And if you have said the variable to be protected, still anybody within the apartment and anybody within the house can access. You did not specify anything, default. Still, anybody within the apartment, anybody within your house can access it. You said it as private. When you said a property of yours as a private, then only your family, only your flat within your apartment can access, but other apartment members, even though they belongs to the same apartment, within the same package, try to understand my point. Within the same package, they cannot access the private data members. They can't access. If you say something as private, only within the class you can access. Okay? This point is already demonstrated. Only within the class you can access, but outside the class, even though some classes belongs to the same apartment, they can't access. Let us imagine that your opposite flat, if you belong to an apartment, your opposite flat cannot access the private belongings of yours. And if you make intentionally some public and protected and default, they can access. But private properties cannot be accessed even though the opposite flat belongs to the same apartment. Same apartment is just like a same package. Okay, great. Now the third point, same package by subclasses. A class that belongs to outside the package and a class that belongs to inside the package. And outside package, if somebody wants to access this one, there should be some relation, okay, inheritance kind of thing. So here let us understand the same package by subclasses. There is no restriction other than private. It is just like within the package. I'll tell you with an example. Now within the package, okay, within the package there are two classes like class A and class B. Class B is related to class A within the package. That means within the apartment. I am talking only within the apartment. Now let us understand. Within the apartment, your flat is A. There is an opposite flat called as B. Opposite flat B is related to you. Let us imagine that your uncle or aunt is staying there. They are somehow related to you. When compared to other flats, flat B is very much neighboring flat to you with respect to some relation is there between your flat and other flat. In such case, same package by subclasses. Since the flat B has a relation with class A, what kind of relation is that? Let us imagine that there are two classes, class A and class B. Class A is base class, class B is derived class. Derived class from class A. Okay, let us imagine father is staying in apartment flat A and daughter or son is staying in flat B. So flat B have an access to flat A. Okay, to what level class B members can have an access to class A? That is what we are going to see now. Even though there is a relation, there is some restriction in case if base class has made any property as private, then even though there is a relation with flat B, those members who belongs to flat B cannot access the variables or functions that belongs to class A, because class A, if you set anything as private, for an example, in class A, if there is a variable as private int A, then even though within the same package, even though you have a class that is inherited from this class, still they cannot access. Private means private, that's all. Private means no other things, no blood relations, nothing else. Within the family, within the class, you have an access. Outside, even though there is a relation with the outsiders, no permission at all. Means within the same package, even though you have a concept called as inheritance, even though you have any kind of relationships, you cannot access the private members of the other classes. Okay, this is the concept. So remaining parts are S. If you have intentionally said public int A, then other members can access. Then protected, still other members can access. Default, other members can access. Same package, subclass is very much similar to within the package. Okay, there is no much difference. So what did you understand from these two? If anybody wants to access the class that belongs to the same package, you need not to have any blood relationship. No inheritance will not play a role. Even though you have relation or not, the same thing. So even though son or daughter stays in flat B, whatever the access permissions that are given to flat B, the same flat C and D will have if they belong to the same apartment on flat A. Okay, so I hope you got the point. Now we are going to talk about one of the important thing, outsider by subclasses. Outsider means the person who doesn't belongs to your apartment. Outsider. Okay, doesn't belongs to your apartment. He is completely outsider, but there is a relation, inheritance relation is there with the flat. Okay, now let us imagine the outsider as X. X is the outsider. You being A, who is staying in the apartment. A is the flat member. Okay, flat name is A. Now, how outsider X can access the properties of A? If X is outsider and if X do not have any kind of relationship, no way they cannot access unless you make any property as public. But in case if X is somehow related to flat members of A, then at what level they can access? This is what I am going to tell you now. So public, yes, if you made anything as public, not only the outsider who have blood relationship, but also anybody, completely outside person without any kind of relation also can access, because public is public, private is private. Okay, these two are very much nearer to the meaning of English keyword, so you don't have to worry. The only thing is that whenever you have protected and default, how the roles changes, this is what you have to observe carefully. Now outsider, he is completely outside of your apartment and wants to access some properties of yours. Yes, allowed. If he or she has some inheritance, okay, if they are somehow related to class A. Let us imagine the outsider extends class A. In such case, if your property is said to be public, then that person can access. And if your property is said to be protected, then also that person can access. And if your property has default access modifier, no, this person cannot access. And if property is said to be private, possible, even though that person had a very good relation with flat A members, they cannot access. Okay, because the property is said to be private. Please try to understand my statements with respect to programming, then that will become much more easier for you. Otherwise, there is no other concept which is as complicated as this table in the entire Java language. In this last example here, let us imagine X is a person now. Okay, in this case, X is an outsider and somehow he had blood relationship or some inheritance concept with the class A who belongs to an different apartment. And here global means X is completely outsider and do not have any kind of relationship, like a Swiggy person coming to your apartment, like a Zomato person coming to your apartment. They don't have any access to, they don't know who you and that guy do not know each other, and that guy, what kind of things that particular person will be given access. Or let us imagine, with respect to programming, let us imagine that there is a class which is completely outside of the package and no inheritance concept. That class is not extending any class that belongs to this particular package. Now, what are the things that can be given access to the outsider? Now we are going to see. If you have said any property as public, yes, not only the person who belongs to your family, not only the person who belongs to the apartment, not only the person who belongs to the other apartment have the blood relationship, but also the outsider who do not have any kind of relation also can access that property, because public is public. Public means anybody can access. Now, since this person is completely outside without any kind of relation, if you said it as protected, no means no. That person cannot access that property. You did not set any access modifier, still that person cannot access anything else. No. You said it as private. 100%, 200% it is no. Private means how a person completely outside without any kind of relation can access your property? Impossible. Done, guys. Okay. This is what this table, really confuses a lot everybody, and we need to remember this thing. And the better we remember this table, just by doing some programs. Now what I do is that I'll create a package. Okay, I'll create a package called as P1, and inside P1 I'll create a class called as A, and I'll create one class. Let that class be demo. Okay, that is outside the package. And I'll try to access the classes of the package that I created. Guys, we are going to do some programs, and please support me and don't look at the time. Okay, don't look at the time. I might take another 10 or 15 minutes. This video may continue for about 10 or 15 minutes. Doesn't matter. Whatever the knowledge that you are going to get today is tremendous. We are going to implement this table. This access modifiers, yes, no. Okay, we are going to test them with simple examples. To best demonstrate what I do is that I'll create a folder called as my project. That is my project. In that folder, I'll be creating a package called as P1. It means that I'll be creating a directory called as P1. Inside P1, within that package, I'll create a class called as A. Come again. I'm going to create a folder called as my project. Inside my project, I'm going to create a package called as P1. Inside P1, I am going to create a class called as A. A is a class that belongs to P1. P1 is a package. In other words, P1 is a folder. Okay, this folder is available in a folder called as my project. Okay, right. So now what I do is that I'll write a program demo.java which is outside the package P1. It doesn't belongs to P1, outside the package. When it is outside, how can I access the class of class A that belongs to P1? This is the concept that we are going to learn. To access class A should be public first of all. Any class has only two modifiers. Either class is public or class is default. There is nothing like private and protected with respect to class. With respect to class members, we have these four: public, protected, default, private. This is with respect to class members. But a class can be public. You can create a public class, right? Public class demo, public class sample. Class can be either public or default. Default means nothing else. Okay, right. But to access any class outside the package, the class must be public. Remember this point. To access any class outside the package, class must be public. First of all, class must be public. To access anything that is inside the class, like variables or functions, that is another story. This is what the story that we have already. But to access basically a class outside the package, we need to declare that class as public. Right now, we are going to create a package P1. Inside P1, there will be a class called as A. Outside P1, I am going to create a class called as demo. Demo will access the class A only if class A is public. Okay, now let's test it. In the same way, let's keep this demo within the package and we'll try to access, and we'll try to use the inheritance concept and we'll try to access it. All these combinations, whatever that I said, I'm going to test now. 15 minutes down, we can complete this tremendous concept, doubtlessly. Now, as I said, carefully follow every movement of mine. Please, it's going to work in your real time. My project is a folder that I created. It is a folder that I've created this because all my project files are going to be kept inside this particular folder. So in this particular folder, I said that I'm going to create a package P1. How do you create a package? You need to write a program for that. Okay, I'm using a simple text editor. These things you can also do using any IDEs like Eclipse and Apache NetBeans. It doesn't matter. Package. What is the package name? I said P1 is a package name that I wanted to create, and I said that I wanted to create class A. Okay, let it be class A. So inside class A, nothing else. So I'm keeping one function. Let the function be display. Let us write system.out.println. Just to this will be displayed on the output screen. It's very easy to understand. So I'm from package P1 and class A. Okay, this will be printed on the screen upon executing. Upon accessing this function display, which belongs to class A which belongs to package P1. Alright guys, right? So we're done. We have written a package P1. Inside package P1 there is a class A. Okay, if I wanted to access this class A outside this package P1, then I said that a class has to be made as public. If class is not public, you cannot access this class A outside the package P1. Okay, alright, now let's save this as the file name is given as the public class name is given as A. That's why my file name will be a.java. So under desktop there is a folder called as my project. Here let us save my file. Okay, so in my project there is a file called as a.java. Now we need to compile this program. How do we compile a program which has package? You already know. It's very easy. So it's already done as part of the presentation. Javac space -d, the same command. Okay, now let's open terminal. I'll go to desktop because my project is available in desktop. My project. Inside my project there is a file called as a.java. I wanted to compile this file. So javac routine compilation you should not do. -d dot space a.java. The moment you do it, Since you have given package P1 folder will be created and a class a.class file will be generated inside P1. Great. So this is what happened. Now let's test. I said P1 folder will be created, inside P1 a.class is generated. Now let's create one file outside P1. So any file that you create here will become now outside P1. If you do not include package P1, then that will never belong to the same package. Okay. Now let me create one file here which is outsider file, and let's try to access A, and let's grab display method. Okay. Right now, let's do it. Now write simple program, public class demo. Demo is the class. Okay, it is I'm not writing any package P1. So I'm not writing package P1 because I don't want demo to be part of package P1. It should be outside of package P1. So inside here I write public static void main string arguments. Okay, so my intention is I want the class A in demo. Class A belongs to which package? P1. So I need to import p1.a. In P1 is a package that is readily available in my current working directory. Inside P1 there is a class called as A. That class I want that A because I want the function inside that class. Okay, it means that you got a key. Once after opening a key, take whatever you want inside. Inside what is there? Display method is there. I want basically the display method to be executed inside my class demo using the package P1. So this is how you need to import. You can do it now because class A is public. You can absolutely import it. Okay, right now here in this case for class for demo. Okay, I'll create an instance obj1. Okay, equals to 1 and new demo constructor method. Demo is a class name, right? Demo is a class name, right? This line I'm creating an instance for this class, the current class. Okay, using this instance obj1 is the instance that belongs to this demo class, but using this instance I'll call the method display. Done. This program is done. Demo.java is a class name and I'll be keeping in the. So one thing, what is the function that I'm accessing? Display. Display is the function that I'm accessing. Now let's check what is the access specifier of display. If access specifier of display is important, class specifier was public, you can access public. Okay, you went into the house, but inside house if you wanted to access anything, then every item is protected with some name. Okay, now let's test what is the access specifier that is given to display. So inside P1, okay, here is itself the source code is there. So inside P1 there is no specifier that is given to display. If no specifier is given to display, an outsider cannot access it. You can check it out the table if you want. Outsider cannot access it. So I should make it as public. If I make it as public, then only I can access display. If I do not make it as public, then I cannot access display. And if I make it as protected, I cannot access display because the outsider demo have no inheritance concept with this class A. That's why it is not extending class A. That's why even protected will not help. Only if it is public, then I can access. Okay. Now let's save and recompile this file. Recompile, that means again the class file is generated because I made a small modification here. I added public because I wanted to access this display. Now I will be compiling this file demo.java. Demo is an outsider who wants to access this display method. Of course he can access because he has imported correctly that package P1, and within the package he had created an instance, and using that instance he is calling the function display. That person can access because this function is made it as public. Okay, so actually what is the function that I wanted to access? What is the function that I wanted to access? Display. Display is a function that is there in class A. Okay, not in demo. Okay, sorry, it was my mistake that I given demo there. A is the class in which there is a function called as display. That function I wanted to access, right? Now let's access it. To access that function, I'll just simply use. So we have accessed this function. Did you see the output? The output is a line that came from a package P1. In P1 there is a class called as A. I have successfully accessed that particular function outside the package. Okay, I did not belong to demo. Is a package. Demo is a class that doesn't belongs to package P1. Still we are able to access that function because that function is set to be public. And of course the class is ultimately public and the function is set to be public, then I can do it. Now let's test in case if function is not public. Let's test it. Okay, in case if my function is not public, if function is not public, then we'll just recompile it because we made a modification here. So java c -d dot a dot java, because I'm recompiling the same file because I made a modification there, because I changed my function is not public now. It is default. It has default access modifier. In the same way, now now let's try to access demo, because demo is accessing display method now. This time display method is not public. It has to throw me some error. I cannot access, right? So java c demo.java. I'm just compiling. Okay, look at here. Display is not public in A. A is a class name. In class A, display method is not public, cannot be accessed from outside package. This is warning. So what exactly we have learned from the table is coming to the reality now. Okay, now what we do is that in case of this, what we do is that let's make it as protected. Okay, let's make it as protected. Protected means only relationships, only the person who had a relationship with this class A can access this one, right? Now let's change this demo class and let us establish relationship with class A. Okay, class A is already imported here. Now demo has a relationship with class A. Even though the class A members are protected, now I should be able to access. Because the class inside class A there is a property called as display, which is set as protected. Now I being outsider, if I had a relationship with class A, then I should be given access to display. Now I don't have to create an instance. I should not create an instance for A. This time I should create instance for demo. When I create instance for demo object 1 equals to new demo. Okay, the moment I create initialize object 1, automatically because automatically the parent is A, parent properties will also get some memory here with respect to object 1, and we can access the parent properties using object 1 reference obj1 dot display. obj1 dot display. Display is a function that is not available in demo. It is available in class A. I'm accessing display method from class A through inheritance, through the concept of inheritance. Since the property is made as protected, even though it is protected, I can access it. Okay, if I do not have extends A, then I cannot access protected property also. I would have got error, just like as in the way I got here for the private. How exactly I got an error? Even though I make it as protected, and if I do not have a relationship, if there is no concept of inheritance, then I cannot. Okay, now I need to recompile this one because I made it as protected. Now I need to compile this java demo dot. Now you can see that compilation was successful. Let's execute. I am from package P1. Okay, so this is how we can test. By doing these kind of similar examples, you can remember the table. You don't have to mug that table. And there is one direct statement. If you know that table and if you know how to use access modifiers, then only you can become Java developer. And if you do not know that table and if you do not know how to implement those table and access modifiers, then you can never become a Java programmer, an effective Java programmer. And remember, access modifiers is not a concept that is related to Java. It is related. This concept is there in every object-oriented programming language, including Python. So private, protected, it's not a thing that is related to Java. Okay, so it is an universal concept. Everybody should have a proper knowledge on it. Now, rest of the things you can test of your own. Okay, keep this demo inside the package and compile it. Compilation, the same command, javac space -d dot filename dot java. Use this concept and test for within the package. You keep demo, keep the inheritance concept, try to access it. Don't keep the inheritance concept, try to access it. If you get any doubts, I'm here. You don't have to worry, I'm here. At any point of time, you can ping me, you can message me, I'll be with you. Okay, great, we are done. It is possible for us to host and upload many demanding courses on this YouTube channel, only if you support us by subscribing. Please subscribe, switch on the notification bell, stay connected, and enjoy learning.